Mitticool clay refrigerator history begins with the cooling action itself. Fill the upper reservoir with water. That water reaches the porous terracotta body. At the outer surface, some of it evaporates into moving air. Evaporation requires energy, so heat leaves the clay and the storage space behind it. The cabinet can therefore keep food cooler than the surrounding room without a plug, compressor, refrigerant circuit, or motor. This is not a claim that wet clay duplicates an electric refrigerator. It is a different machine for a different constraint. The National Innovation Foundation describes Mitticool as a clay cabinet for vegetables, fruit, milk, and water, and records that Mansukh Prajapati completed the product in 2005 after testing soils and designs. The Bureau of Indian Standards later created IS 17693, 2022 for non-electric cooling cabinets made of clay, defining the category through construction and performance requirements rather than through a marketing nickname alone. The mechanism is visible. A top chamber supplies water. The clay's pore network lets moisture spread through the body. Air carries vapor away from the outer surface, and the phase change removes heat. The official product instructions say ventilation improves evaporation and recommend cleaning the exterior every few days so the pores remain open. They also warn that performance depends on ambient temperature and humidity and is strongest in hot, dry conditions. Water, airflow, and maintenance are therefore operating inputs, not optional details. The cabinet form was refined around storage. NIF describes an early version with upper and lower water chambers separated by a food compartment. A later version removed the lower water chamber, reduced the upper reservoir, and devoted more of the lower body to food. That evolution is a useful design record. The cooling principle stayed the same while the arrangement changed to make the object more practical. Packaging was also redesigned so the fragile clay cabinet could travel farther from the workshop. That limit is the point of the story. A compressor can actively move heat against a temperature difference and regulate a cold compartment across a wide range of weather. Mitticool instead uses a passive path whose attainable temperature is tied to the surrounding air. It trades deep, tightly controlled refrigeration for no electrical demand, few mechanical parts, and a material system a ceramics workshop can manufacture. Its value must be judged by whether that bargain fits the food, climate, water supply, and household using it. Begin with the complete household routine. The user places the cabinet in a ventilated location, supplies clean water to the upper tank, allows the terracotta body to become wet, and loads suitable food into the lower compartment. Cooling develops as water migrates through the porous material and evaporates outside. The official instructions say the first cooling effect takes time, so this is storage maintained by a continuing process rather than an instant chill. The routine also includes refilling water and wiping the outside to keep pores open. Electricity disappears from the task, but attention, placement, water, and cleaning remain. That exchange makes the product understandable without pretending it performs every job of a powered refrigerator. Now follow 1 unit of water. It begins in the reservoir, enters connected pores in the fired clay, spreads toward the exterior, and reaches a surface exposed to air. Molecules that escape as vapor carry latent heat away. Heat then flows from the warmer cabinet and its contents toward that cooling surface. Peer-reviewed transport research on clay pot coolers models this as coupled heat and mass transfer, thermal conduction through wet materials, evaporation at the surface, and convection into the surrounding air all matter. The product has no powered pump or compressor. Its material structure and the vapor pressure difference between wet clay and ambient air create the path that moves energy out. Air conditions set a physical ceiling. The Mitticool manufacturer explicitly says performance depends on external temperature and humidity and that hot, dry weather favors the process. The MITD lab model likewise treats ambient temperature, relative humidity, wind, device dimensions, stored vegetable mass, and water use as interacting variables. Dry moving air can accept more water vapor. Humid still air offers less capacity for evaporation. This is why ventilation is a functional requirement rather than styling advice. It is also why one temperature claim cannot be carried from one climate, room, loading pattern, or test method into every home. Honest performance language must stay conditional. The cabinet's origin is documented by India's National Innovation Foundation. After the 2001 Gujarat earthquake, a newspaper caption about a broken clay water filter prompted Mansukh Prajapati to imagine a rural refrigerator that needed no electricity. Nif says he began practical work in 2002, tested different soils and cabinet designs for 3 years, and completed Mitticool in 2005. Those dates describe an iterative product development path, not the invention of evaporative cooling itself. Clay vessels had long cooled water. Prajapati's contribution was to reorganize that familiar material behavior into a manufactured cabinet with a reservoir, food compartment, door, and repeatable household operating routine. Testing matters because food storage is not proved by a cold-feeling wall. NIF reports facilitated trials at a farm science center in Bharuch in which the cabinet interior measured 4 to 5 degrees Celsius below room temperature and several vegetables lasted longer than comparison storage. Those figures belong to that documented test, not to every climate. The current manufacturer describes a 50-liter terracotta model, advises placing it where air can circulate, and notes that performance varies with weather. The careful conclusion is therefore narrow. Under suitable conditions, the cabinet can create a cooler, more humid storage environment that slows water loss and deterioration for some produce. But users must match food safety expectations to measured conditions. Loading also changes the system. Warm produce adds heat. Packed contents alter air circulation, and every open door exchanges the interior air with the room. A measured result therefore describes a complete test arrangement, not a magic property of clay independent of use. The comparison with an electric refrigerator reveals two different infrastructures. A compressor appliance needs electricity, manufactured refrigerant components, seals, controls, and service, but then actively maintains a cold cabinet with relatively little daily water handling. Mitticool needs no electrical connection or moving refrigeration mechanism, yet it depends on a source of suitable water, dry enough air, ventilation around the body, careful placement, cleaning, and protection from impact. Fired clay can crack if dropped, and blocked pores reduce evaporation. Neither system is infrastructure-free. Each relocates the burden into a different network of energy, materials, maintenance, and user attention. Standardization changed the object from one named innovation into a defined product class. In 2022, the Bureau of Indian Standards issued a 17,693 for a non-electric cooling cabinet made of clay. The government press note says the standard specifies construction and performance requirements for cabinets operating by evaporative cooling and intended for perishable food storage where electricity is not required. A standard does not guarantee identical results in every kitchen. It establishes common terms and tests by which construction and performance can be evaluated. That distinction is important. The historical legacy is not only a single workshop's product but the recognition that passive clay cooling can be specified, tested, compared, and improved as an appliance category. The most useful legacy is a rule for judging appropriate technology. Mitticool does not become advanced by imitating every feature of compressor refrigeration. It becomes useful when local clay, ceramic skill, water, airflow, climate, storage needs, and purchasing constraints line up. Its limitations are part of that fit. It cannot promise the same controlled temperature in humid weather, and it still asks a person to manage water and surfaces. Yet where electricity is absent, unreliable, expensive, or unnecessary for the intended produce. The cabinet can turn evaporation into a practical service. No electricity during use should not be confused with no resource cost. Clay must be prepared and fired. Water must be supplied, and a heavy fragile cabinet must be transported. Those costs do not cancel the design's advantage. They keep the comparison honest. The relic is contemporary, an old physical principle arranged into a distinct modern product, with success measured by context rather than power consumption alone.